Hey everybody, don't be alarmed, but they're having us wear these masks now when we're out and about, and been wearing it at the shop. And today I'm at the college and we're gonna talk about some suspension stuff. So I've got the Cutaway here. I'm gonna talk about it. I'm trying to hold the camera and instead of wearing it on my head. So anyway, here we go. All right, so this is a Cutaway suspension system off of a Chevrolet Camaro, and this system is what is called the SLA, short long arm suspension system. So if we get down here and we look at this lower control arm, okay, the green guy, this lower control arm is much longer than the upper control arm, which is the blue guy. All right, and back in the day, they used to have equal control arms on the lower and the upper. The problem with this is when you went over bumps, the arc, the wheels are, we try to get the wheels to move exactly straight up and down, all right, but because they can't, they have to move in an arc. So what would happen with equal length upper and lower control arms is that the wheels would actually take a travel out and then back in. And as this happened, you would get tire scrub, and it was wearing out tires at a pretty quick pace. So with this SLA upper shorter control arm and the longer lower control arm, that sway, that arc is minimized. All right, so the tire moves pretty much straight up and down. All right, so the control arm on the upper as well as the lower has bushings in them, and the bushings are meant to keep metal to metal contact. And so these bushings twist, so they kind of act like bearings, so they allow some twist action as the controllers are moving up and down. Do they wear out? Oh yes, they will wear out. Okay, on this suspension system design, when we go to adjust our alignment for camber and caster, we would use shims between the frame here and then the actual control arm rod here. And so we could move it out, okay, and maybe not out so much on the back, depending on how I wanted to change my caster. All right, and then of course down here at the lower control arm, we have the same thing. We have the bushings in there, which are kind of difficult to see because it's dark. So let's shoot from, yeah, and they're hidden. All right, but believe me, there's control arm bushings there as well. This is what we call our jounce bumper, because as the upper control arms move up and down, we call it jounce and rebound. As the control arms are moving up, we're compressing the coil spring, and we call that jounce. So as the control arms are moving up, we call it jounce, and then as they're moving down, we call it rebound because of the stored energy in the spring. So this is a jounce bumper, and the idea here is to keep the lower control arm from contacting the actual frame. All right, so those can wear out as well. Okay, and then inside of here on this yellow piece, this is what we call a shock absorber. The job of the shock absorber is to control jounce and rebound. The spring doesn't control it. The spring only supports the weight of everything sitting on top of it. So the frame, the car, the engine, the transmission, the whole drivetrain, the people that are sitting inside of the car, that's the job of the spring, is to support all of that. All right, something else I want to show you is the ball joints. Okay, the ball joints allow motion in both a up and down movement somewhat, so as the upper control arm and the lower control arm are moving in that arc, it pivots back and forth. All right, and then the next thing it allows us to do is allows us to turn the wheels left and right. So then we have this movement back and forth this way. Now, one ball joint is called the loaded ball joint, and the loaded ball joint is going to be the one that has to have spring pressure against it. So on this particular design, the spring is going to normally be all the way up against the frame, and then it's going to be pushing down on that lower control arm, which makes this ball joint at the lower control arm the loaded ball joint, and the upper ball joint is what we call the unloaded ball joint. So I have a question for you. Which ball joint do you suppose would wear faster, the loaded or the unloaded? If you said the loaded bearing, the loaded ball joint, you are correct. All right. So, of course, we have two sides to this deal. So we have the driver's side, and then we have the passenger side. Exactly the same, we hope. All right. If not, then we're going to have problems. Okay. So again, the area where I can adjust my alignment for camber and caster. All right, my bushings, my ball joints, all right, my spring, my shock absorber, and then I also have my steering column, or my steering knuckle. That is what everything kind of attaches to. So the upper control arm as well as the lower control arm attached to the steering knuckle. All right, so since we're here, let's talk about a little bit of steering. So this particular steering setup, all right, has my steering gearbox. Inside of this steering gearbox, and I'm sure you've seen it on in your chapters, we have a sector shaft, and then we also have a worm shaft inside of there. And they have balls that ride up in there, and as I turn the steering wheel, right here at my inlet, this is where I'm going to be turning my steering wheel, it's right there. All right, comes into the gearbox, and as I turn that, we move this pitman arm back and forth. Okay, so the pitman arm, the red thing, steers the vehicle or moves the tie rods and then the steering knuckle left or right. Okay, and then right here, this yellow part is my center link. And then from my center link, I have an inner tie rod end, white, and then I have an outer tie rod end, which is also right, and then I have the adjustment collar in between the two. So I have that on both sides of the vehicle. Okay, and then the last thing we have for this particular steering system is my idler arm. Now, you may have recalled when we were doing that Chevy truck, it was kind of the same setup, only a lot more beefy. But the idea behind this design is to keep everything parallel. All right, the center link needs to stay parallel to the vehicle at all times. So we call this the parallelogram steering system. If let's say I have this idler arm that wears out and allows this center link to droop down a little bit, what that does is it pulls the toe in on this side of the vehicle. So on the passenger side of the vehicle, it would pull that tire in. So now we're going to be wearing tires when we shouldn't, and we're wondering why, because all of my parts seem to be okay. Well, guess what? This is the most common thing in this design to fail, is the idler arm. All right? So just like on the suspension system, we have not necessarily ball joints, but we call them tie rod sockets. This socket allows movement both up and down as I'm going up and down over bumps, and as I'm turning, it allows a little bit of swivel action inside of those sockets. So in most cases, I'll have one at the inner tie rod end, I'll have one at the outer tie rod end, okay, and I also have one here at the idler assembly, and depending on the design, I may also have one here where the pitman arm hooks up. All right, so there's your parallelogram steering system. This is my power steering pump that pumps pressurized fluid into my steering gearbox, and then it has a return line to return that fluid back to the pump. And of course, the pump in this case is going to be driven off of belts that the engine's going to be supplying power to as it's turning. That creates pressure inside of the pump that pressurizes the fluid to the gearbox for easier steering. All right, so parallelogram steering system, all right, and then my SLA, or short long arm suspension system. GoPro, stop recording. All right, we are back. So another type of suspension system I want to talk to you about is this is a lighter duty, more compact suspension systems that they started using on front wheel drive vehicles, and we're starting to see them used on other things as well, even some rear wheel drive vehicles. It's what we call the McPherson Strut suspension system. And what's unique about this is that, number one, the coil spring is incorporated onto the same unit as the shock absorber, okay, that you can kind of see inside of there. It's kind of hiding underneath the bellows, but the actual shock absorbing unit is down on this end. All right, what this eliminates is it eliminates the need for the upper control arm, because the upper portion of the strut acts as the control arm. On the front, it also has a bearing in here that allows the wheels to be turned back and forth. There's still going to be a lower control arm, however, that will be used to allow that movement up and down and the pivoting on when I'm taking corners. We can also have McPherson Strut suspension systems on the rear of the vehicle. It'll still have the lower control arm, but of course typically it doesn't turn. So this bearing up here, okay, won't be needed. It'll just be mounted in there. All right, so I'm going to show you a picture of this system on the vehicle. One of the other things I did find on the SLA is I wanted to get this control arm out for you so you guys could get a better look at it. We were talking about the bushings that are used to allow movement up and down as we go over bumps or we go into dips. And then here's kind of a better picture of the actual ball joint. So the ball joint allows, again, like I said, action. It can twist, it can turn in there. So we can take corners as well as we're going over bumps and we're flexing, going up and down, that we can see that this ball allows that kind of movement. All right, and then another thing I wanted to touch base on with you today is another type of steering system that we will typically see on, again, it started with the front wheel drive vehicles. It eliminated a whole bunch of parts. You don't have a center link. Well, I mean, the rack acts as the center link, okay? But we don't have things like, we don't have an idler arm. We don't have a pitman arm. All we have is what we call this rack and pinion. So I still have outer tie rod ends. And again, that allows my movement all around, all right, as I'm taking corners and going over bumps. And then it has this inside tie rod that's kind of hidden underneath the bellows, but it allows for that same kind of movement. All right. This type of steering system called the rack and pinion kind of got its name because what lives inside of this housing right here is the rack gear. And the rack gear is attached to the inner tie rods. And then this is my pinion right here, that the steering wheel shaft comes down, all right, and fits over this. And as I turn the steering wheel, then we start to see movement of my tie rods in and out. All right. So the rack and pinion, it's lighter duty. It's not as heavy duty, so it can get damaged a lot easier. But again, it's so compact that it allows more room in there for other things like the transaxle, okay, the transmission that the front wheel drive units work with. So let's go over and take a look at McPherson Strut suspension system, and we're going to be looking at this Ford over here, this Ford Windstar that we worked on with front brakes and on-car brake lathing. All right, so as I come around the corner here, you can see the awesome work that you guys did on the rotors for the braking system. But the one thing you're going to notice is there is no upper control arm. There's our strut, our McPherson Strut. All right, and way up at the top where it attaches to the vehicle's unibody frame is going to be that bearing so that the wheels can turn back and forth. All right, and then there's my spring and then my shock absorber, kind of all in one unit. All right, and then you can see that this is where my outer tie rod end attaches to my steering knuckle. All right, and then here is my lower control arm. All right, now it's not even looks like a regular control arm, it's just got this rod sticking out. So I'm going to raise this up so we can get a better look. All right, so now you can get a much better picture of this little lower control arm here. All right, so it's got its bushing where it attaches to the subframe, and then it comes out here, and then there's my lower ball joint. All right, and that attaches to the lower portion of my steering knuckle. This also has what we call a trailing arm or a strut rod. Okay, lots of different names, but it has a bushing on this end, and then it comes forward through the frame to the bushing on this end. Now what this does is it keeps our whole McPherson Strut and lower control arm assembly from moving forward or aft as we're rolling down the road. We wouldn't want that to happen. So that's the job of this strut rod. Okay. Other things that typical suspension systems have would be this anti-sway bar, okay, stabilizer bar. Again, there's lots of different names for it. And then it's hooked to a stabilizer link that's mounted up to the strut. All right, and what that does is it helps to stabilize the vehicle as I'm rolling around corners. Because as I'm rolling around corners, let's say I'm taking a left-hand turn, what's going to happen is as I take that turn, the left side of the vehicle is going to want to rise, the right side of the vehicle is going to want to dip. And what this does is it counteracts that to try to keep us going around the corner as level or as horizontal as possible. Okay, so that's pretty much it. Here's my transaxle assembly, and then as you notice, it's going to be kind of hard to see because there's no light. So let me see if I can get you some light. Hold on, because I want to show you that rack, the rack and pinion on this guy. So I'm going to get us a little bit of light back here. All right, and you can see the rack and pinion. All right, you can see up there, this is where the steering column shaft attaches to the rack. All right, and then you can kind of see this is the bellows for my inner tie rod on this side. There's my outer tie rod on this side, and then we have the same thing going on the passenger side. So there's my outer tie rod, my inner tie rod. All right, and it's a lot more compact. It can actually be bolted in the back of the engine area instead of at the front of the engine area. All right, and it just opens that up so that we can get more stuff inside the same size compartment. All right, let's see. Anything else I want to talk about right now? No, you know, I think we're doing good. So I'll let you see this. You guys can think about this. We'll probably have some conversation about it. And I'll talk to you later. GoPro, stop recording.